Okay, AP Physics, it's Mrs. Hartman again with your video of the week. This is number 2 for this week. I want to talk to you about some basic ideas of projectile motion. The first time you go through projectile motion, it can be a little tricky. If you've taken physics before, it's maybe you'll pick up some tips or tricks here, otherwise you might be just good to go. Projectile motion can be a really simple thing if you think about it as two separate things that are happening at the same time. You have horizontal motion that is occurring and free fall. So we just did both of those in Unit 2. We did constant linear motion and we also did accelerated linear motion. And free fall is accelerated linear motion. So let's look at projectile motion a second. If we look at an object that is, let's say we've got an object right there, a ball, and it's going to roll off of a table, okay? If this ball rolls off the table, it leaves the table with velocity that's just in the horizontal direction. Now, as it loses contact with the table, it will start to fall, and it will fall only due to gravity. So it takes this curved path because it has velocity in the x direction. And as you're going to see when we get to forces, it has inertia. So it's going to keep moving in this x direction because there is no horizontal acceleration. So it keeps moving forward. Meantime, gravity kicks in, and we see this arc because it starts at a velocity of 0 at the top, and it starts to slowly gain more and more velocity in the y direction as it falls because gravity is accelerating it. So we can take a look at this as two separate motions the entire time, okay? And actually, if you take a ball and you drop it and launch it horizontally, they will actually hit the ground at the exact same time because they're going to fall at the same rate due to gravity. And you might hear my bulldog in the background. I don't know what he's seeing, but he may not like projectile motion. So we can just look at anywhere along our projected path, the initial horizontal velocity will equal horizontal velocity at any given moment, okay? When we have the y velocity, if we have horizontal projectile motion, okay? So you're throwing it at a perfectly 0 angle, something's rolling off of a table that's flat, any of that sort of thing. Your initial y velocity will equal 0, okay? From there on out, your y velocity will be dependent upon two things: gravity and time in the air, okay? So we're looking at free fall again, okay? If we want to combine the two, now we're looking at two different vectors. So we're going to have to add the vectors. So your overall velocity would then be the square root of vx squared plus vy squared. All right, didn't want to draw that. Okay, so now let's move our page and let's take a look at angled projectile motion, okay? So now we have this nice arced path, okay? And when we have this, we've got some initial velocity, and part of that initial velocity is in the x direction, and part of it is in the y direction. Okay? Now, just like horizontal projectile motion, that x velocity at any point on the path is always going to be the same. It's never going to change. Okay? So here, it's still Vx0. Here, it's still Vx0. Here, when you get to the top, it's still Vx0, or not. Here, still the same, all the way through the entire path. No matter where you are, that initial x velocity remains the same because, again, there is no acceleration in the y direction. Now, if we're looking at, or in the x direction, there's no acceleration. But in the y direction, there is acceleration. And so we look and we see that as we go up, our y velocity is going to get smaller. And when we reach the top here, the y velocity is actually 0. Okay, right there. This is a really common question that gets asked in the multiple choice section of the AP exam. And you have to read it very carefully. Sometimes you will be asked, what is the y velocity at the peak of a projectile? And the y velocity is 0. Sometimes you're asked, what is the velocity at the peak? And the velocity at the peak is only equal to this Vx0. So the projectile is still moving. It's only moving in the horizontal direction, though, at that moment. And then you see we start to come down and we have Vy, and the speed is increasing as we get closer and closer and move further and further under the influence of gravity. And from there, we can then use our vector addition to find the overall velocity at any given point. So then we know that V is equal to the square root of Vx squared plus Vy squared. Okay, hopefully these are a couple little overviews, and if you break things down, that should help you. One last thing that I also have for you is a problem-solving method I like to call GUFSA. And that stands for given or givens, unknown or unknowns, formula or formulae, solution or substitution, and answer. Okay? If you use this and lay out your problems this way, it becomes much easier to pick which formula you need to use. If you write out what you're given, and when you write out what you're given, don't just write the number. Write Vx equals or Y initial equals. And it's easier then to see then what fits the formulas best. When it comes to the unknown, it's very simple. If I only have one unknown, then I only need one formula. But if I have two unknowns, then I need two different formulas. So use this problem-solving method, use the basics that I've shown you here, and hopefully that'll help get you a little bit further with projectile motion. If things aren't coming to you, let me know, and I'll pull an example.